My name is Carlos Gonzalez, and I'm a technical marketing lead at Cisco in the IoT business unit. And today I wanted to share with you a platform that we just recently released. Now, you see the Catalyst name in the slide, and it's very familiar. There's a lot that we're taking and we're sharing from the Catalyst family, and I'll get into that in a second. But just to get started, let me just tell you what it is. And we're talking about the Catalyst IE9300 series switch, and it is an industrial platform, right? You saw the switches that were previously presented, campus type of networking. Do they play in IoT because they connect things that play in the Internet of Things? But this particular family of switches, as all the other ones that we play with in the IoT business unit, are ruggedized platforms. So you see the color is different, and there's a real reason behind all of that. But what makes this platform very unique is that it's an all-fiber platform, and I put that in perspective in a second. It's stackable, so what you heard about Stackwise before, we are bringing that into the IoT, the ruggedized switching families. It's a rack mount unit. Now, you're used to rack mount units, but in the industry, there are different classifications, DIN rail in some verticals, rack mount in another, and I'll get more into that. It's running iOS XE. That's important for us, and I'll expand on that as well. You may be used to that iOS, but it's a half and half mix of what we're running on IoT platforms just because of the history behind things. But it's critical for this new platform, and it's managed by Cisco DNA Center, and that's very significant as well because traditionally we are being managed by other applications, Cisco Prime, if you remember that, and all. We're just trying to level set the field and have a very robust management and control of that network through this. Now we say things like unrivaled performance and scale. This is within the industrial market. This platform brings things that are very unique. Unprecedented visibility. So now we're digging even deeper into the traffic, into the applications. Again, in the industrial side of the house, things move in a different pace, things and needs are differently. Review and upgrade cycles on automation and digitization cycles are different. So all this stuff is very exciting on our end. Security and so on, so forth. So I just wanted to flat out tell you a couple of things on the platform and then give you the context on why this is needed. And in doing so, there's a bunch of needs that are coming into the industry, into the industrial market. Again, we're not talking about data centers or campus, we're talking about industry, where there's the need for hybrid work, as the slide shows, grid resiliency, improved efficiencies, and agile operations. Imagine the need to collect more information from your sensors out there on oil and gas or pipelines or in train tracks or toll booths or even in your substations and in your power grid, right? More need to collect, more need to be efficiently remotely accessing and protecting those. The same things with increasing the flexibility within each of those networks in order to move with market changes, right? And overall protect it. So that brings into play a new set of requirements for us. And that set of requirements are all about having higher visibility of the networked equipment. So we're no longer talking about, can you see the switch? Can you see the router? We need to see what's going from point A to point B as far as traffic. And you have the traditional traffic in your data center. When you move into the industrial side of the house, you have another menu of protocols that we need to understand, communication, and trying to make sure that we agree on what's going on. And if we don't, what kind of security it's put in place to make sure that all that stuff is saved. That brings us to the second high-level security requirement. Cybersecurity standards, right? So not only have the traditional security in the network, but we also have a deeper view into the protocols and what can we allow or not, secure postures and things like that we need to play with. More capabilities in smaller footprints. So these are not new constructions, these are not new buildings, these are new warehouses. Some of these are small panels, small buildings on the side of the road, right? And that is prime real estate. So we need to pack more features and reduce footprint in order to help that market migrate into newer technologies, expand services, and protect even more. So that's very critical. Then that brings high resiliency, right? We do have traditional ways of protecting network, redundancy, ring protocols, spanning tree, rep, and things that you may be familiar with. But on the industrial side of the house, there are very key applications that may not survive a simple hit, right? So you need to find seamless recovery or seamless failures, right? Where something can fail, but but the end-to-end traffic is not impacted at all. So no traffic loss. And there's some industrial protocols that provide that we do support, and we play part of it. And then on top of all that, this whole concept of timing, where in the data center side, in all those networks that we're used to, you have things like NTP or network time protocol, where you can keep things synchronized for multiple reasons. Now, the level of precision that offers is perfect for the implementation, but in the industrial side of the house, precision it's key. There's a need to synchronize platforms to the tune of nanoseconds, and that synchronization is paramount for the survival of that critical infrastructure. So we also play a lot in that in very specific areas. So that's the context behind it. How we solve that, it's pretty much by taking the strength of what you've seen. Now you saw some latest and greatest on the Catalyst family. We're taking strength from the Catalyst family and put it in service of the industrial market, right? We take from the Catalyst 9200 and so, and we're repackaging them and making them the built for harsh environments, make them resilient and certified for those key placements, and then bring the right set of features and complement them with industrial support, right? And in some case, these features are very they're critical, but they're very familiar to all of us. They come from the data center side, they come from the networking side, campus network, and so. But in the OT side of the house, in the operation side of the house, on the industrial market, a lot of them are new, and we're just trying to build new use cases in order to expand the survivability, expand the implementation, expand the options for those markets, right? So there's a blur of the IT and OT side that we're doing, and in order to do that, we need to rely on the strength of a successful deployment of platforms and features that in the Catalyst family. And then because we're doing that, they bring some level of familiarity. You heard before that those catalysts are using the UADP ASIC. That comes into play into the 9300. Absolutely everything that comes to it as far as deep diving into application type of recognition and performance, that is part of our 9300 family now. But also you have the same software, so when things are developed on one end, they can easily port it into the other. So fast delivery of features and functionality. And then the management, right? So now your IT side can keep using DNA Center and expand its view into the operation, into the OT side, and without having to jump through hoops with other applications or third-party platforms. All that said, that's the context. There's a big need. We have strengths on the Catalyst family of Cisco. We're bringing them into service of the industrial. And that's not to say that we were not doing that before, but we were actually hitting the market with the right set of tools and features in our other platforms. This right now opens up a very aligned future for us at Cisco and IoT. So what are we releasing, or what we did release in early in January this year? So two models, the 9310 and the 9320, and you can see some logos there. We'll go into a little closer look into the hardware itself. But what are the highest the features, the key features that we're bringing from one side and building on top of for the market on the industrial side? So performance, we talk about performance. You were mesmerized with the performance of the Catalyst 90. The other family that was presented before this, that's insane and amazing. We're bringing some of it to the needs of our verticals in the industrial side. 100 gig bandwidth with platform with backplane extension, and the idea of that is definitely be very, very mindful of delay and jitter, be very, very mindful of line rate needs as we help grow those verticals, right? Oil and gas, train, toll booths, mining, and utilities. The second thing that's very critical and is new to us on the IoT side is stacking. We had stacking before, but in a different way. Now we're taking the stack-wise implementations from the Catalyst family into these IoT environments, and we'll be able to stack up to 8 of these platforms, not only expanding the density of ports, but also increasing your performance and increasing your reliability as you either daisy chain them or manage them as a single entity. So we're doing all of that under not much complexity at all. You see one switch, now extra ports, extra ports, extra ports. And then you can get creative in how you implement those things in a substation or on your manufacturing floor if that's what you decide to do. The other part that I mentioned before was critical, which was the need for higher precision on the timing side of the house. So we do support, obviously, PTP, which is Precision Timing Protocol, and there are different profiles in it that some market spaces or industry spaces require. Power profile, the default profile, wine profile. This platform looks into the default and power profile because it's focused on that side of the house. But because of the performance that it brings, each hub or each platform in a chain, depending on how you're implementing it, would only add 50 nanoseconds of accuracy there, which means that as the timing is going through your network, the platform will have a very minimal impact on the difference of going in and out. And the other part of it is a lot of hardware timestamping there that we're doing at ASIC level, so all ports will do that. We'll see a little bit more in a second, but it's critical because things like substation automation, there's a specific requirements how much each node can add, like a microsecond or so on the timing impact, and this platform is way below that. So it's critical. The other part that I mentioned before was resiliency. So we not only have support for spanning tree and rep, but on the industrial side of the house, we need protocols that are a little bit more stringent and resilient. We support HSR, or high availability seamless redundancy, and PRP, your parallel redundancy protocol, which rely on having sending duplicate frames, either in the case of HSR in a ring environment. So if you lose one side, the other packet will make it. So it's all based on sending redundant frames, but the underlying architecture is what and support is what makes it possible. So where we were looking at resiliency protocols before as a network resiliency protocol, in the industrial side, there's an integration of that resiliency protocol between the infrastructure and the end nodes. So you have IEDs or intelligent Ethernet devices that speak PRP or speak HSR, and they need to communicate with our switches, and we can build an even more resilient implementation. Then there are other protocols that are also industry ones, MRP or Media Redundancy Protocol, DLR, device level ring. Those are also implemented. Those are not seamless in their protection. Where HSR and PRP, you should have zero packet loss, but they do provide requirements that the industry needs.
There's a question on Twitter from Peter Jans Nefkins, who's asking about the protocols that are supported on the ruggedized gear, various industrial protocols. He's wondering if those are also supported on the regular campus Catalyst 9300s. So is that, I guess, basically, is that a unified Cisco iOS XE software, or are these features licensed?
That is a very good question. So they're key features, and I'll show you a slide in a minute that has the bulk of the features that we're bringing in, the different licenses. But the majority of the features are shared as IOXE, right? That code is shared among multiple platforms, and we bring in feature parity with the Catalyst families as much as is needed into the industrial side of the house. However, when we're talking about industry-specific protocols, like I mentioned, HSR and PRP, those are more on our side of the house. Those are more of IoT type of implementations for ruggedized. They don't play much on data centers. They don't play much on campus networks. They're more of industrial, like in a manufacturing floor. We see them looking at HSR definitely on utilities, PRP, and HSR, and so on. So some of the key industrial ones, you'll see that they're very specific, and I'll show the slide. They're very specific to the ruggedized family of products. All right. So on the other side, and we have you heard before again, edge compute. So in the industrial side of the house, in IoT, on the ruggedized side, we do need that as well. We do have some platforms in our portfolio that will support applications, Cisco and third party. This is the first one on the rack mount ruggedized families that will support IOX edge compute, and that places it closer to where the information is really being gathered, right? Gets closer to the nodes where you have your sensors, get closer to that, so you can do some pre-conditioning, pre-hashing, pre-showing of the information before you need to send it through a network to any centralized analytics application. But that opens a bunch of possibilities. Third-party Cisco-approved applications. It opens up to the next square in that slide, and that's CyberVision. And CyberVision is an endpoint security application that we have that runs on sensors in the network, and it can see what traffic is flowing from where to where, from what end node, what protocol it's talking to what level of security is there, what changes in configuration are happening. There's a very robust way of understanding what's happening in the network, and then with that, you do your security postures and understand exactly what's allowed, what's not allowed, and then implement policies or deploy policies and profiles that will allow for a higher level of security. And that is possible because you running the sensor in the switch itself. You're not running it as an appliance, as a compute, as a Raspberry Pi or any edge compute device. It runs on the switch, which is where the information is going through. Then we build on top of that with some extra levels of security. MACsec, we do 128 and 256. Highlighting 256 because that's the most stringent one, and we support it on the platform. That's for your level 1 or physical layer type of encryption. And then we build on top with being the new platform on our side that will be an edge node or a fabric edge node when we do SDA access. That is something that is coming. We're developing all the use cases for that so we can bring that knowledge and that, open the creativity of how to use that in the industrial side where you're expanding the enterprise reach into some of these nodes. And again, you push policy, you push configs, you push control to these nodes. Now, the bottom line, and I'll go through that super quick, is it just builds on top of of having iOS XE and having and inheriting a good chunk of strength from the Catalyst families, right? Flexible NetFlow, streaming telemetry, NBAR for deepen the view into applications. So that's for application recognition. The same with SDAVC. So you're doing that as a software-defined application visibility and control supported there. Layer 2 and Layer 3 NAT, and I know we're very familiar with Layer 3 NAT, and that plays here as it plays in the data center and it's plays in campus. But Layer 2 NAT is very critical in some manufacturing floors, the way the manufacturing nodes and devices are being configured, are being deployed. Layer 2 NAT is critical for that floor. So that's supported here. You're familiar with things like span, where you take traffic from one port, divert it to another one, so you can capture it, and if you know what's going on in the network. There's remote span that extends that over a Layer 2 network. We're doing also encapsulated RSpan or encapsulated remote span. And why that is critical is because we use it for CyberVision, and we also use it to send the traffic to any kind of network security setup, right? So either Cisco or not, but we managed to send that over an IP network. So you encapsulate it in GRE and send it over instead of having to be constrained to your Layer 2 network. And then things like 802.1x for authentication and all that. So the bottom line on all this is that we do provide strength from the Catalyst family, but this set of protocols and this set of requirements are new on these platforms, are new to the market space on the ruggedized IoT side of the house. So that's very exciting, and it has us all just very geekly.
Just get a question from somebody on Twitter, and he is asking, as well as PTP, will there be support for time-sensitive networking .1Q enhancements on the roadmap?
So we do TSN. We're looking at that in across our portfolio. There's some clean implementations and things that are being looked into. This platform, it may be a topic for discussion as a roadmap item, just because of where we're targeting the deployment of this platform at the beginning. And just to be very, very clear, so the answer is not a no. The answer is it's open for discussion in this product line. We are more advanced in the other ones, especially the ones that dive into the manufacturing floors. And so we're TSN, it's more talked about. Here, the synchronization is more of we need to bring that GPS signal down to the network, not mess with it, keep it real, keep it very precise, and feed those end nodes. So their communication and their sync up, it's very precise. So short answer, roadmap conversation for this platform is already ongoing in other platforms in the portfolio.
Perfect, thank you.
Cool. Can the system clock be synchronized with PTP? I know some switches require NTP instead, and they can't sync using PTP. Just curious about that.
So so short answer is yes. So there's different modes in PTP, border or transparent clock. Depending on what mode you use, you synchronize the clock of the platform with PTP, and then you can turn around and spit out any other timing protocol, right? So you can translate from PTP to NTP or so. But yeah, you can synchronize the platform's clock with PTP.
Thank you.
Yeah, absolutely. And then you have the different profiles and all that stuff. But this device, it's these two platforms that I'm talking about, and we'll see a little bit more soon. There are two of many that are coming down the line. If you're familiar with our other rack mounts, you see that PTP is a very critical part of them, and it's being implemented and deployed. So it's not new to this platform. It's been out there for a while, and different models and different modes are available. Now, super quick on this slide. This is what's said. Well, not the only thing, but this is one of the things that you'll see these platforms that you won't see in any of the other Catalyst platforms. These are purposely built for industrial environments, right? So each vertical, each environment will have very specific requirements and things that we need to comply with. So these platforms get certified, make sure that we're compliant, so we can deploy and we can actually ensure the functionality and the survivability of that network. Right, so there's some examples there on energy, on oil and gas, transportation, city, manufacturing, and mining. Those are just a few of the ones that the platform is certified and compliant with. The data sheet has a laundry list of all the ones that it goes through, so you know. And then you have different country-specific ones that we also provide. But the whole idea is this platform, you can throw it into -40 or +75. Vibration, dusty environments, high humidity. It is sealed, no moving parts, no fan, and we'll see a little bit more of that in a second. All right, so these are the two platforms, and what I'm going to do is I'm going to have that slide and go through it, but I wanted to change the view here on my end a little bit to some real platforms that I have right next to me. And the whole idea is this. There's two 9300s that we have announced and we are actually selling right now, the 9310 and the 9320. Like I said, this is the beginning of a very healthy roadmap. So just bear with me for a second. High fiber density, and again, very critical on the industrial side because we used to have either all copper or a mix of copper and fiber, but now we've been asked, hey, we need more fiber for multiple reasons, and we'll see some of those requirements in one slide further down. But not only oil and gas, it's a lot safer for fiber, but longer spans and distances can be taken on by fiber. Less space on conduits, and and the newer platforms require fiber connectivity as well. New platforms, sensors and edge nodes, and then this platform can also not only play on the access side, but also as an aggregation. So we need to aggregate maybe other Cisco IE switches into this one. Obviously, the uplinks are going to be fiber uplinks. Like I said, two of them, they look very familiar. One are U 19-inch rack mount devices. But here's just a quick view. So 24 SFP ports. And I know it's following the previous presentation that doesn't look like much, but it is quite a bit on the industrial side, at least in the market spaces or industrial market spaces that we're targeting. The whole idea is this: you have 24 SFP ports, 22 of them are dedicated SFPs, and 2 are combo ports. You use SFP or you use the copper, but that doesn't stop you from using copper SFP or small factor pluggables that are copper based, right, on the other ports. So you can mix and match in this case. Yeah, you don't have PoE on this one. The requirements are not there for this platform to support PoE, at least on the markets that we're targeting right now. Further in the roadmap, you'll see that mix again. We do have it with our other platforms, but in this case, SFP is the order of the day.
The choice to use SFPs, is it purely for flexibility, or does it offer some sort of extra ruggedness, like for protection against dust or anything like that?
That's a very good question, Bruno, because one thing that I missed to say is that we have a very long list of SFPs that we support, right? Pretty much the SFPs that you're familiar with, up to 1 gig in this case, are supported here. But there's also a family of ruggedized SFPs, right? And those are the ones that have the most stringent specifications for heat and dust and humidity, and those we do sell and those we do support in this platform. So you have, depending on where you're deploying it, you might have that that option. Then I'll move a little bit faster. The other things that you'll see in this slide here are just common to all the switches. Alarm contacts, console connections. Ways to look at what's going on by cycling through deep switches in the front. Obviously, storage, SD card, USB. So this is one thing that is very interesting here. So we do redundant power supplies, and they're field replaceable, and they are very familiar because they're ones that we use with our previous platforms, rack mount. So there's some element of not having to revamp everything. You can reuse as you either expand or replace with this platform. The key difference between these two devices, and I'll need to move a little bit faster, is the stacking port on plain view, right? You see the 9220 do support stacking, the 9310 doesn't. And we'll talk a little bit more about that. And those are these stacking ports that you see here with this tiny cable here. The rest of the implementation is pretty similar, pretty much looks the same. Now,
speaking about the SFPs, I'm sorry for jumping out. Somebody is asking if there's a dust cap for the unused ports.
Yeah, you can get dust caps for them, absolutely. Yes.
Fabulous, thank you.
All right. So I mentioned that stacking was one of the key differences, but basically we stack them up to 8. It's the StackWise 160. So if you're familiar with that, that's what we're using. Cannot mix and match them just because these are industrial protocols and it's very specific to which ones you match. So you cannot bring a Catalyst 92 or 93 and plug into this guy, and because then that's kind of confusing. But the thing is, like to like on our side of the house. And the other key difference that I wanted to mention, not only stacking, but the 9320 has an FPGA that will allow for the support of those key protocols that I mentioned before, PRP, HSR, MRP, and that's one of the key difference there. The other thing is the stacking port that I just highlighted. Both of the platforms aside of that will have the same level of scale and performance capabilities, and we can make that information available as needed. Software, iOS XE, and we talked about it a little bit. It's very flexible, it's built for automation, and it's very capable. So bringing that in the industrial side. 2 key areas, and this is the part that gets very interesting. 2 key licenses, Essential and Advantage. And the reason why I mentioned that here is because of this. This is a busy slide, and I know we can get that slide from any platform that we have in our portfolio. But what I want the industrial customers to understand is we're getting all this functionality from our Catalyst family into this platform, and it's at the default level of your license, right? You don't need to jump extra hoops to get all those security protocols implemented or that QoS or any of that. And if you see that bucket there that says, that line that says industrial Ethernet, those are protocols that are specific to the platform, right? Supporting of key protocols on SCADA, or when we're talking about power profile, or on the PTP side of the house, and some of the other protocols that I mentioned on redundancy. Then if you want to take advantage of a little bit more layer 3 routing or virtualization, or up the ante on the security side with TrustSeg and Max at 256, then you need to move to that advantage. But you get a very healthy line of features there.
Rep brings resilient Ethernet protocol.
Yes, absolutely.
And then in the previous slide for this licensing, with the other catalysts, if I want to get Network Essentials or Network Advantage, the initial purchase requires DNA Essentials or DNA Advantage, which comes with the corresponding Network Essentials license. Is that the same licensing model here?
No. Here, by default, all of them come with Essentials. You don't need to buy the NIC license with it. That's optional, right? But if you need the Advantage features or the Advantage features in DNIC, then yeah, you need to have some parity there. But one thing that I wanted to leave you with is we meet and exceed the requirements on each of the markets that we're trying to hit with this platform. These are just very high-level requirements that we get from Substation, from utilities, rugged hardware, fiber optic communications, and there's a list of reasons why, but we do target that with this platform. Timing and distribution, I talk about PTP and how that works. Seamless failover, so we do support those protocols, and they're real. There's no traffic loss there. Increasing cybersecurity, we do with the things that we do in the platform, plus bringing cybersecurity in, And being a new platform, there's a expectation of a long life ahead. Every time they update a substation, that stuff is going to stay in there for 10, 12, 15 years. So those customers don't want to see something that we're going to be shifting and changing every now and then. So we do provide that answer for our customers. Please go to these pages. It's all the information is out there. Hit us with questions, and I will make sure you get everything that you need.